Okay, Alok, so let's start your thermodynamic snap. And as you mentioned, you are preparing for Bihar Public Service Commission, Assistant Professor Examination, interview.
So interviews. Yeah. Right.
Okay. Yes. So, Alok, my first question is to you, what is thermodynamics?
So if you have to define thermodynamics, so then thermodynamics, the word thermo means thermal energy, and dynamics means it transfer. So the transfer of energy. So thermodynamics are basically thermodynamics. We can define in much better way as that. So it's a branch of science, which mainly deals with the energy interaction from the system and the surrounding and its effects. So it carries the effects also. Means it deals with energy interaction and its effect on system and surrounding. So,
What do you understand by stored form of energy and transient form of energies?
so stored form of energy means internal energy is the stored form of energy, sir. And transfer form of energy means the energy which is getting transferred. Means suppose we have a control volume, so if we supply heat from one side, so that form of heat is that form of energy is transferred form, transient form of energy. And the things after supplying heat, it may absorb some heat in terms of internal energy, and then it will do some work also, so that will again comes in transient form of energy, sir, work.
Look, what do you understand by conservation of energy?
So conservation of
Energy.
hello. So conservation of
Conservation
energy,
of
sir.
energy. Yes.
So conservation of energy means, sir, it means something which is get conserved. So like our first law says that for any cyclic device, if the net heat interaction is equal to net work interaction. So sir, this is all about the cyclic device. But when we go for suppose for we have a several paths, then this says that for a different path we have a heat interaction, and some energy will get stored, and then some work will be we obtain some work, or it will deliver some work. But when we add all these processes together, then their summation of that heat will be equals to summation of the work. The internal energy becomes zero there. Total the sum of internal energy becomes zero. So this will give me a sense of a conservation.
So if you'll consider washing machine as our system, okay,
So
normal washing machine which we are having at our houses, domestic purpose which we use. So how you can write the first law of thermodynamics for a washing machine?
So for a washing machine, as it is an open system, so we will use our study flow energy equation to write for it, sir.
Can you write?
Sir,
Can you write some energy balancing
sir,
system for a washing machine?
sir, like we haven't supplied heat first of all in that. So the first thing will be the velocity part. That is so first thing will be that enthalpy part. That is H1 plus at the inlet I'm talking, and then we will have the dynamic part, that is C1 square upon 2. Then we will have the sir, this potential part, that is GZ1, and then that will be equals to at the outlet we have enthalpy part, and then at the outlet we have again the velocity head, that is C2 square upon 2 suppose, and then we have this potential head in terms of GZ2, and then it will deliver some work. Then we have this flow works, right?
Okay. Is like suppose other than washing machine, if you will simply consider a kind of motor, electrical motor,
Okay, sir.
will there be any difference in the analysis?
So electrical motor, for electrical motor, like given we have given work done is on the system. So through that electricity, we have given transfer the work to that particular system, and that that transfer of
Can you write some equation for the energy balance?
so energy balance, like study flow energy equation will give me H1 plus 1 square upon 2 plus GZ1 plus Q is equals to H2 plus 2 square upon 2 plus GZ2. So this is GZ2 plus work. So, so this could be the energy equation, steady flow energy equation for any open system, sir.
So why you are considering motor as an open system?
Sir,
What you are considering as the system? The motor or some kind of air which is entering? What you are considering as a system?
system that motor, sir. Only. That
Motor is a system. So is there any mass entering
Right.
into the system? Mass entering,
No,
mass.
sir. No, sir.
So why you are writing that steady flow energy equation? Mhm.
So this I got a little confused, sir.
Look, can you give me one example of open system, closed system, and isolated system? Real
Sir.
life example. Yes.
So real life. So open system means, sir, when we have a both energy interaction as well as the mass interaction, right, sir? So, for example, sir, in case of our IC engine, we have this open system phenomenon, and sir, for the closed system, we can say that when we have only energy interaction, there is no mass interaction. Mass interaction is restricted. So, suppose, sir, we have a bottle of water, sir. Suppose we have a bottle of water. So that water is, suppose we have a chilled water, right, sir? When the water temperature is around 15 degree or 10 degree something, right? We have taken some bottle from the fridge, suppose, sir. Then what we will see is when we will place in the surrounding, sir, then what we will see is although the bottle is closed, so it's a closed system. So we will see that over the surface of the bottle, sir, there is a water droplet, sir. There is a water droplet. So, that is not the inside water, that is the outside water which get condensed over that cold surface. So here there is no water which is coming out of the bottle, but there is an energy transfer which led the outside water or atmospheric water to get condensed. So it is one of the example for the closed system, sir. And sir, for isolated system, our inverse is the best example for this, where no interaction of mass or energy happens.
Alok, what is entropy?
Sir, basically, sir, entropy is mainly driven from the when we start learning this second law of thermodynamics, which says that the second law says that second law talks about the qualitative property of that particular system. So entropy means, sir, unavailable energy with respect to the surrounding. That will leads to entropy, sir. So suppose entropy means a randomness in the system is related to entropy. So if we will say that the entropy is more, then the unavailable energy, which is not able to convert into the useful work, is unavailable energy, sir. So that amount of energy is more in the system. That led to the entropy, sir.
Alok, whether we are taking an example of a washing machine or motor, in all these cases, we are converting electrical work into mechanical work only. So what do you feel? These
Right.
kind of conversions, the conversion of work into work only, that is a kind of reversible process or irreversible process?
So these all are irreversible processes.
Why? Why irreversible?
Sir, it is mainly because, sir, it is although the work is high grade energy, right, sir? So high grade energy into another high grade energy. There is an so this is all related to that conversion of energy, which is mainly
very right. But here, in all these cases, we are carrying out conversion of work into work only. So where is the irreversibility? Right. If I'll ask you in that way, can you find out the irreversibility associated with that conversion, which you are carrying out in a fan, ceiling fan, motor, or a washing machine? How you are going to calculate the irreversibility?
So irreversibility is only associated where we are having a heat transfer. Means lower grade energy. When we are talking lower grade energy, sir. So for higher grade energy, irreversibility.
Yeah, that lower grade energy is coming. You are getting one question, look. You are getting mechanical work. You are giving electrical work. So where is the low grade energy?
Right.
Yes, there is low grade energy, but where?
Sir, suppose because we cannot transfer the total energy, right, sir? from suppose we are giving some work, and that in the output also we got suppose some work. So there will be some losses from the system. So that losses with respect to its surrounding will tell me about the entropy.
What is entropy generation?
Sir, entropy generation means, sir, it is basically when the process is irreversible, then the total entropy, that is ds, that will be equals to del q upon t plus this generation part. So it will be always positive, and so for this much I know about this particular.
What is available energy?
So available energy means, sir, there could be two definitions of it. One thing is that when we are dividing the low grade energy, then we have two types of energy. That is, one is available energy, another is unavailable energy. Available energy means the energy which the heat which we are able to convert into the useful work. That will be available energy. So sometimes we also say that the maximum amount of energy which we can extract from a system, such that the system will attain a dead state. Dead state means thermodynamic equilibrium. It should attain thermodynamic equilibrium. Then that energy is called as available energy.
My last question is to you, Alok.
So
you are about van der Waals equation.
Yes, van der Waals equation.
So for what kind of gas we use this equation, and can you write that equation, Alok? How this equation is different from ideal gas equation?
Sir. So can I explain it then after I should write it? So ideal gas equation, as we know that PV is equals to nRT, right, sir? This is ideal gas equation. Sir, when we have to write the when we are writing the ideal gas equation, we think that, or we assume that the intermolecular force is negligible, and the volume contained by the each molecules should be very less, or it is in terms of minusculous. It is very less from the system dimension. So there is a huge space between one molecule to another molecule, such that they can travel it, right, sir? So we take it that form as a ideal gas, and in that only ideal gas, the internal energy is the function of temperature. They are only temperature. Then when we talk about real gases, these two molecules which was away from each other, when we are talking about real gases, these two molecules will come, the distance between them will decrease. Sometimes they may associate with each other also, these gases. So this distance decreases, so intermolecular forces get increases. So the size of that molecules, or the volume of that particular, will be greater. So when we are writing PV is equals to nRT, or PV bar suppose is equals to RT, this V bar is volume, PV is equals to nRT, then we write it as P plus A by V square.
You want to say that in ideal gas assumptions, there are very less number of molecules per unit volume. Real gas,
not less, sir. It is like, sir, when we in thermodynamics we have used this macroscopic approach and microscopic approach. So in microscopic approach, the density becomes very rare. So that kind of a condition we assume it in ideal gas equation, sir. So this will give me this, sir. So this first equation is of ideal gas, and another this equation is of, sir, real gas. So in this we have two parts, sir. In this we have two parts. One is P plus A by V square. A by V square, this A will take care about the intermolecular forces, because now in real gas these intermolecular forces are very high. So this will up, if A will be 0, then it will only P, that will convert into the ideal gas. Then we will talk about this V minus B. This B is considering that volume occupied by that real gas. Although if B will be 0, it means the volume occupied by the each molecules is very less as compared to the system dimension. So it will tend toward the system dimension. So this V minus B will take care about this part will take care about the molecular dimension.
Okay.
So thank you, sir.
Okay. Overall, look, it's looking fine. You're looking sincere. I think your technical knowledge is also looking fine. But you need to improve your delivery, and very important critical points you need to highlight. So I started with the what you understand by stored form, transient form. So try to keep the answers very much simple and straight. So stored form means energy which can be stored in a body, okay, or which can be stored by the inside the mass, like the kinetic energy, potential energy, internal energy. So those kind of energies are known as stored form of energies. But sir, there are some energy which cannot be stored by body. Okay, those energies which only we can observe at the boundaries only, like heat and work. Okay,
Right,
so they are known as what, the transient form of energy.
yes.
कंजर्वेशन एनर्जी तो आपने ठीक बताया, कंजर्वेशन ऑफ एनर्जी. अब हाउ यू कैन राइट दिस फॉर ए फैन और वॉशिंग मशीन और ए काइंड ऑफ motor? So what you are doing, you are converting electrical work into mechanical work. So you can write equation dq equal to de plus dw. dq equal to de plus dw. This is a equation you can write for any process, any system. Yes or no?
Right.
Any process, any system. Now suppose you are having a motor, and if that motor is in steady state, motor you are having, and motor is in what, steady state. So what will be the change in energy of the motor? That will be zero in steady state. Why? Because motor is a kind of stationary body, stationary system. Although the shaft is rotating, but it is not displacing from its position. So there is no change in potential energy also, and there is no change in internal energy also if the motor is in steady state. Okay. So after reaching the steady state, initially obviously there must be change in the energy, and that change in energy you can replace by what, change in internal energy. Why? Because motor is a kind of stationary system. dE you can replace by du. But if you are assuming motor is also in steady state, then du or dE will also be zero. Okay. Now what is work? There are two forms of work. One is the negative work, electrical work, which you are giving. Electrical work, that will be negative because there is a work done on the system. Plus that there is another work, and that work is what, mechanical work, which you are getting. Whether you are having a ceiling fan or washing machine or any motor. What is this Q? Q is the heat input or Q lost? Obviously lost, because some part of the work is converting into heat due to the friction. That is known as the dissipative effects. So due to friction inside the system, work converts into heat. And whenever work converts into heat, the reversal is not possible completely, because you cannot convert again heat into work completely. That's why those processes are what? These processes are irreversible. Why? Because due to friction की वजह से क्या हो रहा है? Although you are converting work into work only, but not completely. We are converting work into work, but not completely. And whatever work we are losing, that is what? That is irreversibility. So you have taken much time actually, answering this particular question. But later stage, finally you answered. But how to write the first law of thermodynamics, that you have not answered. So Q lost. Q lost will be positive or negative? That will be negative. Heat added to the system is positive, rejected by the system is negative. So which equation you will have finally? Minus Q lost equal to minus W electrical plus W mechanical. If you take minus common from both the sides, what you will get? Electrical work minus mechanical work. That is equal to what? Q lost. And that Q lost divided by temperature of the surrounding. Where that heat is going? That heat is going to the surrounding only. So Q lost by T naught. That is what? That is the entropy change of the surrounding. Yes, generation. You can mention it as entropy generation also, because the system is in steady state. So entropy change of the system will be zero. And entropy generation again multiplied by TO. That is what? That is irreversibility. So whatever heat we are losing, that is a irreversibility. Means whatever is the difference of mechanical electrical work minus mechanical work, that is a irreversibility.
Sure.
Are you getting? Hello?
Right, sir. I got it.
So entropy generation is nothing but the change in entropy of the universe. The change in entropy of system plus surrounding, that is known as entropy generation. Obviously, it is not a property. It depends on the extent of irreversibility. More is the irreversibility, more will be the entropy generation. And entropy generation is always a positive quantity. It will be zero for a reversible process, but for a irreversible process, it will be negative. I asked you about available energy. What is available energy? It is the maximum work which you can get in a reversible cycle by bringing the system to the dead state.
That is.
That is known as available energy. AC को बोलते हैं exergy.
So,
So overall, wonderful questions you answered finally, but initially I think you mentioned some wrong point related to the number of molecules, but finally you corrected and you answered it right. So overall, it's fine. Look, most of the part you answered, you tried on the right line, but you know, it is my suggestion to you, try to keep the answers much more straight and simple. Don't make it complex. Okay, you need to convince the interviewer, and if you're able to convince the interviewer, they will show interest in you, and they will obviously give you the advantage. Okay, overall it's fine, Alok, but yes, revise the subject again, and you need to join me again after 1-2 days whenever you feel yes, I revised again this particular subject. So you need to go for 1-2 snaps, Alok.
So one thing I'd like to say, sir, while answering, suppose if you are asking me that what is a system or what is a reversibility, so while answering it, there is a lot of things which is I know it. I know what is available energy.
Actually, you know,
But while answering it, I thought that
I got the point, Alok. You need to take time when you are listening to any particular question. Just think for 2-3 seconds, and then start answering. And don't be in a hurry. Actually, don't feel yes, you need to answer very quickly. No, it is not like that. If you are going for some kind of teaching position, in that case, what I feel you need to convince the interviewer. You need to show your understanding about the particular subject. Okay, so take some time after getting particular question. Just take 2-3 seconds, think for a while, and then start answering, so that you know your mind will get sufficient time to recall the things. Okay, and then you will be easily able to effectively able to answer. Okay. So it's look like slightly you are looking in hurry. So take your time. Okay. Any other thing, Alok?
nothing, sir. Sir, one thing more that, sir, actually, I have prepared the other subjects also. One by one, I was preparing. And sir, now it's like thermal portion I have covered. And sir, currently I'm pursuing PhD. So, sir, the thermal portion I have covered, sir. So one by one, I should give snap to every subject, or first of all, I have to complete the thermodynamics part fully. Then I should jump to the next subject. So although I through copies
you can
and
go for any other subject.
So,
thermodynamics you revised, so you can daily basis you can plan your revision. Okay, there is no such problem in that. But yes, you can go for some other subject snap also. That will be good. So don't limit yourself with one subject only. Go for other subject snap also. Okay.
thanks a lot.
Okay, hello. Good luck and yes, best of luck for your interview.
Thank you, sir.